Welcome to RGES Algebra 1. This is Lesson 7B, and the topic is going to be solving harder equations. It will cover 4.1 and 4.2. I do want you to take notes. I want you to title it just as I have here, and every time I write in black, I want you to write that on your notes. And that will go in your notebook as well as being checked week by week. Okay, so that's just an accountability thing. Now we're looking at harder equations. We care that we gather like terms. In other words, let's say I have a problem like this. I'm going to give you the method for solving your equations. First off, we're going to simplify what's on the left and what's on the right. Simplify each side. Then I am going to bring constants to the right side, variables to the left side, and then I'll probably have one last multiplication or division. So let's go ahead and show you that technique several times. I'm going to have you write a couple of them down, and then we'll do a lot more that you will not have to write down. Okay, so the first problem says 2x minus 8 plus 7x equals 19. I'm going to simplify the left side by gathering my x terms. These are both the same kind of terms. They're the same variable to the same power, in this case the first power. So if I have 2 x's and 7 more x's, I have 9 x's. Copy the rest of it down just as you see it. As I see it is 8, there we go, equals 19. Now, that was step number 1 because the right side does not need simplifying. Now, move the number to the right. What do? I have to do the opposite. So rather than subtracting 8, I need to add 8. And I'm going to get 9x equals 27. And then I'm going to take care of I don't need to move variables to the left because I have no variables on the right side of the equation. And then I'll do my last division by 9. Okay? And so I'll have to divide by 9, and so 27 divided by 9 is 3. And that's just a perfectly good way to do it. Now to substitute in, to check my answer, I would say 2, going back to the original equation, 2 times 3, go ahead and write this down to check, minus 8 plus 7 times 3. Does that equal 19? Well, multiplying out, I'm going to get 6 minus 8 plus 21 equals 19. Okay. And I'm checking to see if that's a true statement or not. I'm going to add my positive values. That would be 27 plus a negative 8. Opposite signs take the difference. That would be 19. And that does equal 19. And so it checks. Okay. Sometimes I'll ask you to show that checking step, but it's always a good idea to plug it in mentally. Now I want you to take out your textbook, and I want to talk to you about several more problems on page 131 and 132. So go get your textbook and turn to page 131. Put the tape on pause. I want to talk through several problems together. We're not going to write anything for these. I will write something perhaps on the board, but I'll be in another color. So we're just going to evaluate these together. The first step would be gathering the terms on the left. I would end up after my second line, always copy the problem. And the second line should look like 8x equals 56. And then you would divide. You can see, you can almost start doing these in your head, can't you? The next one, number 2, would be 9x equals 45, and then divide by 9. Number 3, 3x equals 15, and then you would divide by 3. Number 4, 8 minus 3 is 5x equals 35, and then you would divide by 5. Now, when you get to 5 and 6, that's more similar to what we would do. The first step, this is much more complicated. Number 5, okay, not that difficult for you, but you would get 7x plus 8 equals 22. Then I would subtract the 8, and then I would divide by 7. Number 6, I will get 8x plus 7 equals 31. I would subtract the 7 and divide by 8. So hopefully you're following these, and these make a lot of sense to you. I'm going to do just through 10, step by step, and then we'll look for anything else that might be more complicated. Number 7 says 10x minus 7x, so I get 3x plus 18 equals 6. I would subtract 18, be careful with signs, and then divide by 3. Number 8, I would get 3x plus 21 equals 15. I would subtract 21, be careful with signs, and then divide by 3. Hopefully this is very clear to you. Number 9, the last two problems that I want you following along verbally before you even attempt to do these on paper would be 5x minus 7x. That would be negative 2x, be careful on that, plus 21 equals 27. Subtract 21 and then divide by a negative. So my answer is going to be negative. And finally, 6x minus 10x would be minus 4x plus 2 equals 22. Subtract the 2, no problem there. Divide by a negative 4, so my answer would be negative. Looking on here through the first 20, notice number 20, number 19 and 20, little bit more steps because I have, let's see, in number 20, let's look at number 20. I have a 3x plus a 5x plus a 6x. That's 14x plus 4. Don't forget to write. Don't put this as your first step. Write out the problem as your first step. And then write the next step. You can gather those terms. And then I would subtract 4 and divide by 14. Okay, I want to review 21 through 30 with you very quickly. 21 says simplify 3x minus 4 plus 5x. Now notice I cannot solve it because I have no equal sign, but I can gather like terms, and that would be 8x minus 4, and that's all I can do there. 22 it says evaluate 0.3 plus 4.7 times 2. So what would I have to do for that one? I would have to take my 4.7, I would multiply it first, and then I would add. All right, so this is step number 1, and this is step number 2. Number 3, it says evaluate it. This is all review ideas. 3x plus 4.9 if x plus 4.9 if x equals 5. So this is that substitution. Plug a 5 in, say 3 times 5, and then add your 4.9. Simplify. 24 is a good one. 24 is one that tends to have errors. Why? Because I have a negative in front of a parenthesis. You're going to think of this. This is a subtraction. So subtraction means to add the inverse or the opposite. So I'm going to change that to a positive. What's the opposite of 2x? Negative 2x. What's the opposite of minus 11 plus 11? Okay. So that's one way to do it. Another way to do this would be to distribute a negative as a negative 1 times these. Whoops. Okay. And I want to erase this for a minute. Okay. So, negative 1 times 2x is minus 2x. Negative times a negative is positive 11. I probably like this technique better. I have nothing else to combine with this, so I like to write my x's first and add 4 plus 11, or 15. So this is an important one. Make sure you can do that on your own. Number 24. Now number 25 takes the absolute value of 4 minus 13. 4 minus 13 is the same as 4 plus a negative 13 within the absolute value sign. So I'm simplifying what's in the absolute value before I take the absolute value of it. So opposite signs take the difference, which is 9. My greatest value is not the 4, but the 13, so I would take the sign associated with that, and the absolute value of a negative would be its positive counterpoint. Now make sure that you are simplifying what's inside here first before you take your absolute value. Number 26 says 2/3 x minus 10. I want to evaluate that if x equals 24. So I would plug in a 24. Now let's do this very carefully. Times 24 minus 10. So I'll be able to get a value because I've plugged in a number, and all I have here is numbers. Now that means 2 times 24 in the numerator over 3. Very critical idea there. Minus 10. I can cancel then because everything's a factor over here in this fraction. 3 goes into 24 8 times. So 2 times 8 is 16. Nothing in the denominator now. Minus 10, or 4. So this is another good problem to be able to do on your own. 27, write an expression for 12 less than x. That would be x minus 12. 28, write an expression for the product of 6 and x. The product is a multiplication, so 6 times x increased by 5, plus 5. 29, name the axiom. If I have AB times C equals A times BC, I've kept it in the same order, ABC, ABC, but I have changed my parentheses, and so that is the associative property. And what operation do I have? Addition or multiplication? So this is the associative property of multiplication. And 30, name the axiom. If A equals B, then B equals A, and that is the reflexive property. I'm sorry, the last one. If A equals B, then B equals A, where I'm putting them on the left and the right side, that's the symmetry property. Reflexive property simply states x equals x or A equals A. So do the problems assigned for that, and now we're going on to 4.2. More difficult equations, this time where we're using the distributive property. So our example would be and we are going to go ahead and write again on your notes because I'm in black. First we're going to distribute. Then we're going to simplify the left and right sides by gathering like terms. That would be adding up all the numbers together and adding up all the variables of each type together. That would be like terms. Okay, simplify each side of the equation, left and right side. Then numbers move to the right of the equation, and variables move to the left of the equation, and then you'll have a final multiplication or division, perhaps. Okay, so let's go ahead and do that problem. We're going to have 6x x minus 2 plus 5x equals 43. I'm going to do my distribution first. This becomes 6x minus 12 plus 5x equals 43. My next step will be to simplify the left side of the equation by gathering these like terms. That would be 11x minus 12 equals 43. This should be at this point, you should be on very familiar ground. Take my 12 to the right, my number to the right, by adding 11x, that would be 55, and finally my last division, x equals 5. Again, to plug it in, I'll just do that orally with you. 5 minus 2 is 3. 6 times 3 is 18. 5 times 5 is 25, and that equals 43. So we're good. Okay, let's look at another problem. My steps will be to distribute both twice, then to gather like terms on the right side of the equation. My left side of the equation only has the -1. Then to move variables to the left, numbers to the right, and do a last division or multiplication. Put it on pause and try to do this one yourself, and then unpause it and watch me go through the steps. Again, going through this very carefully, I've distributed. That gives me to this step here. Then I'm gathering my x's together and my numbers together. I wrote this as a plus, a -30 plus 8. I could have, as a plus a negative 22, because I'm going -30, far in that direction, back a little bit in that direction, so I'll have negative. Okay, so hopefully you got that. I like to move my variable to the left. You could do this in reverse order in this particular case, but I like to be consistent. So I'll add 7x to both sides. I'll add 1. So you've got -22 plus 1, so -21, and I divide by 7, giving me -3. Now, if you'll get your book out again and look at page 134, I'd like to do some work with you orally. It asks us on page 134, A in the middle of the page, asks us just to identify the distribution portion of the problem. This would look like 24x plus 42, 6 times 7, 42, and then continuing to just add everything else, plus 2x equals 9. For B, you'd have 10x minus 15 plus 4x equals 11. For C, just doing the distribution, I'd have 12y plus 4 times 5, or 20. D, just the distribution part, 18z minus 12. And hopefully you're not having any trouble with those. Let's go on a few more because we have negative signs now. E would be -8x minus 6. Now I want you to be able to do all of these in your head. Minus 24 plus 16x. The negative times negative makes it a plus for the second term there. Number G, just the distribution, would be 18 plus 3x. H, the distribution would be a -2 times 3x, so that would be, let's do H. Actually, let me change color. Okay, so I'm looking at this. This would be the same as, I can be thinking about this way, plus a -2 times 3x plus 7 equals 8. So changing this subtraction to a plus of the opposite. Now distributing becomes clearer. This becomes a -6x, and this becomes a -14. Okay, so you would have 4x minus 6x minus 14 equals 8. Is that clear? Okay, so you would combine these. That would be -2x minus 14 equals 8. Add 14 to the other side, divide by a negative. So your answer's actually, if you add 14, it'll be positive, divide by negative, and it'll be negative. Okay, so I think you're getting the idea of that. It says solve and check for 4.2. I only want you to write the checking out for the first 5 problems. I would say be very careful on problems, especially 31 through 39 odd. 31 through 39 odd would be much trickier, so be careful with those. And then I would like to talk to you together and have you take notes on these. 41 says 9x plus 35 equals 4x. Okay, I'm going to, okay, so not sure quite why they're thinking this is challenging, but we're going to subtract, maybe because if I do that, I'll be left with nothing over here. Let's see how that works. So I'll have 9x minus 4x, that would be 5x plus 35 equals, when I'm left with nothing, I'll put a 0, and then I'll subtract that. So I'll have 5x equals negative 35. Now divide by 5, and I get negative 7. So if I plug that back in, that works out just fine. Not sure why he thinks that's too tricky. Let's look at the next one. 8x plus 21 equals 5x. I guess I'm just assuming it's this step. 3x plus 21 equals 0. That's a 0. Subtract. 3x equals negative 21. Divide. X equals negative 7. Check that out and make sure that works. We get negative 56 plus 21 equals negative 35. Let's see, we're going to take the difference. 5 minus 2 is 3. Negative 35 equals negative 35. So, not sure why that's tricky. Let's look at the next one. So this is problem 43. Go ahead and put it on pause and see if you can work out to the end on your own, and then we'll discuss it. Now this one indeed did have a surprise ending, because from our second step, we have 12x minus 12x. So my x's drop out. 12x minus 12x is 0x, or 0. Okay, so then I end up with a statement 17 equals 17. So my question is, when does 17 equal 17? And your answer is always. So any solution, any x that I put in there will make the statement true. And the reason why is this quantity minus this quantity would be the same each time. And so that's kind of interesting, isn't it? Okay, and then let's do 44. Again, I'd like you to go ahead and try to solve it on your own, and then look at our answer together. Here is the problem. Go ahead and put it on pause so you do your distribution, gather your like terms, and see what this one comes up with. Again, we get a very odd answer. This time is 17 equals 18. Notice what happened again is my x's drop out. But when does 17 equal 18? Never. And so the answer to, that's an R, so the answer to this problem is no solution. That means there's no x you can plug into that equation to get the right answer. So those are some funny things that can happen. I want you to check on 45 through 50. You don't have to do them on paper, but make sure you know how to do those. Come and ask any questions. Let me just review 45 with you. The property for that one, negative 1 times s equals negative s. That's the identity property of multiplication. And number 50, x times 1 over x equals 1. That's we're multiplying by the inverse, so that's the multiplicative inverse property, and you get the identity when you're done, okay, which for multiplication is 1. All right, so everything else should be straightforward. Make sure you can do those at least mentally before you come to class.